Welcome to Grade 9 Chemistry. The very first learning competency we are going to discuss is on describing how the Bohr model of the atom improved Rutherford's atomic model. So if you want to follow through with some sort of a reading material, you may get your Science 9 Learners module and open it on Unit 2, Module 1, pages 1 to 9. As usual, this video is going to be divided into three parts. The first part is a discussion, which is about Bohr's and Rutherford's atomic models, and then it's going to be followed by a pre-assessment, which has multiple choice items, and then the last part is a discussion about Bohr's atomic model and the energy levels. So yeah, let's get this started. Way back in grade 8, you were introduced to the concept of Joseph John Thomson's plum pudding model. So by then, it was accepted that the electrons, which were negatively charged particles, were embedded in a soup of protons, which are positively charged particles. Now, the number of negative charges evens out the number of positive charge, making it an electrically neutral atom. And if you are going to shoot like a negatively charged particle or a positively charged particle, then they have to be following a particular behavior. Okay, so halimbawa, you're going to shoot a negatively charged particle to a negatively charged particle, such as an electron. That particle that was shot must be, deflected because like charges repel. And if you shoot that same negatively charged particle to a positively charged particle, such as a proton, then kailangan magkaroon ng attraction. So you were also introduced to that kind of idea so far in the earlier stages of your, science studies, right? Now, we also found out that in grade 8, that the plum pudding model was not the functional model. Okay, so it was not a model that can express why matter behaves in a particular way. In the work of Ernest Rutherford and a team of scientists who helped him through the alpha scattering experiment, they found out that the alpha particles that were supposed to just have a uniform behavior when hitting a thin gold foil, they seem to have different behaviors. So instead of just having a uniform pathway that they can just go pass through matter just like this, because may mga kalat-kalat na mga negative charges dyan, so they can just pass through matter supposedly through Thomson's model without bending or without being deflected. Okay, so if that were the case, if Thomson's model was correct, this was supposed to happen. But with Ernest Rutherford's alpha scattering experiment, that was not the case. They observed that some of the alpha particles, they were bent in a particular angle, and then some of them naman, like a very small number of them, were deflected. Okay, so why was that so? It seemed like, according to their observations, there is this solid portion of the atom. There's this solid portion of the atom that is comprised of particles that has the same charge as the alpha particle, and later we knew that the alpha particle was positively charged. So that center must also be positively charged. Yeah, so let us turn this around. All right, let us slow it down. All right, let me repeat. What Rutherford and his team of scientists observed is ganito. Instead na mag-pass through lang yung mga positively charged alpha particles, okay, sa atom, if Thomson's model is correct, may mga alpha particles na de-deflect. May mga alpha particles din na parang nabebend with a particular angle. And it seemed like dun sa observation nila, parang merong isang solid part ang atom na kapag tinamaan siya or tatamaan pa lang siya ng ng alpha particle na positively charged, parang madedeflect, parang meron siyang ganung klaseng force na ide-deflect niya yung positive charge. Okay, so ganon. Ganon yung na-observe nila. And so, Rutherford was able to come up with his nuclear model of the atom with a positively charged nuclear center with the protons and a neutrally charged neutron surrounded by a negatively charged cloud of light electrons. So, medyo nabubulol ako. I'm so sorry. Okay, so, ayun. The nuclear model is comprised of the nucleus, okay, comprised of the proton and the neutron, and then merong cloud of light electrons around it. So, that was the nuclear model of Rutherford. Now, the nuclear model was the newer version of the model. Okay, but despite its efficiency in explaining a few simple characteristics of the atom, the nuclear model can be used in explaining other important characteristics of elements, such as why some metals will glow dull red to yellow to white when heated. So, yeah, even though in this video we are not really going to talk about, this in details, kasi syempre, I am actually producing this video to cater to grade 9 students. Okay, so, and in the learning competency, we are not really supposed to dig deep into this. Pero one thing that I would like you to remember is that, one thing that I would like to understand is that, the model of Rutherford is not the final model that we are using. Okay, it is not the model that we are generally accepting nowadays, even in our classroom. Okay, so meron siyang limitation. And what is its limitation? It can explain other important characteristics of elements, such as their different colors when subjected to flame tests. So in this example, you can see lithium, strontium, sodium, copper, and potassium glowing different colors, okay, in this flame test. Hindi yan kayang i-explain ng nuclear model ni Rutherford. But another model of the atom could do that, and it is Niels Bohr's atomic model. So in his experiments, he discovered that electrons move in infinite orbits around the nucleus. So the electrons, the negatively charged particles, they can move from one energy level to the next. So that was what he found out in his experiments. Now, scientists found out as well that it is impossible to locate electrons in the atom for a specific time. This module leads to the discussion of the quantum mechanical model that is used today. So this video will be leading to that. Pero hold up. So ano naman ngayon ang mayroon kay Niels Bohr? And is this what we are using in our schools? And today, actually, hindi rin. So Niels Bohr's model was able to tell us that the transit of electrons from one energy level to another is causing that glow, okay, of the element when subjected to a flame test. So when an electron, such as sodium, when an element such as sodium has its electrons moving around those orbits, then that action of moving around releases a form of energy that is only unique for sodium. And in this case, it will glow like in this color. Copper naman, yung mga electrons niya are constantly moving from one energy level to another, and that movement from one energy level to another will be emitting a form of energy. In this case, a light energy that will be of this color, and it is only unique for copper. But again, this is not the atomic model that we are using today. So what do we call this atomic model anyway? We call this as the planetary model. Kasi meron siyang mga orbits. If this is like the sun, the neutrons and the protons in the middle are like the sun, and then the rest are just orbited planets or other celestial bodies for that matter. So the atomic model that we are using today is called the quantum mechanical model. So, yeah. We will be pausing muna, okay, sa ating mga discussions, and I am going to give you several items for pre-assessment. So I hope that you will get your notebook or, a clean sheet of paper and answer the following questions. Question number 1. Based on Rutherford's model of an atom, which subatomic particle is present in the nucleus of an atom? A. Proton and electron. B. Neutron and electron. C. Proton and neutron. D. Proton only. If you need more time, you can pause this video. If you have decided to continue, that means you can proceed now. We can proceed now to question number 2. In the first and second energy levels of an atom, if the first and second energy levels of an atom are full, what would be the total number of electrons in the atom? A. 6. B. 8. C. 10. D. 18. If you need more time, you can pause this video. If you have decided to continue, that means you are ready for the third item. Which atomic model was proposed by Schrödinger? Letter A, nuclear model. Letter B, planetary model. Letter C, raisin bread model. And letter D, quantum mechanical model. If you need more time, you may pause this video. If you have decided to continue, that means we can proceed to question number 4. Which electron transition results in the emission of energy? A. 3p to 3s. B. 3p to 4p. C. 2s to 2p. And D. 1s to 2s. If you need more time, you may pause this video. If you have decided to continue, we can proceed now to item number 5. The symbol N in the Bohr theory of atomic structure refers to A. The energy of electron. B. The total energy of the atom. C. The number of electrons in an energy level. And D. The orbit in which an electron is found. If you need more time, you may pause this video. If you have decided to continue, that means we can proceed to question number 6. Which of the following sublevels is designated? Is correctly designated? A. 1p5. B. 3f9. C. 2p6. D. 3d11. If you need more time, you can pause this video. If you have decided to continue, that means we can proceed to question number 7. How many orbitals are in the third principal energy level? A. 3. B. 6. C. 9. D. 12. You may pause this video if you need more time. If you have decided to continue, that means we can proceed to the next item. Item number 8. Which configuration is possible in an excited state of electron? A. 2He, 1s2. B. 1H, 1d1. C. 11Na, 1s2, 2s2, 2p6, 3d1. D. 10Ne, 1s2, 2s2, 2p5, 3s1. If you need more time, you can pause this video. If you have decided to continue, that means we can proceed to the next item. Item number 9. What are the orbitals present in the fifth principal energy level? A. S orbital. B. S and P orbitals. C. S, P, and D orbitals. D. S, P, D, and F orbitals. If you need more time, you may pause this video. If you have decided to continue, that means we can proceed to the last item. Item number 10. For a neutral atom with the electron configuration of 1s2, 2s2, 2p5, 3s1. Which of the following statements is false? A. The atomic number is 10. B. The 1s and 2s orbitals are filled. C. The atom is in the ground state. D. The atom is in the excited state. If you need more time, you can pause this video. If you have decided to continue, that means you are ready to check your own work. For item number 1, the answer is C, proton and neutron. For item number 2, the answer is C, 10. For item number 3, the answer is D, quantum mechanical model. For item number 4, the answer is 3p to 3s. Letter A. For item number 5, the answer is D, the orbit in which an electron is found. For item number 6, the answer is C, 2p6. For item number 7, the answer is C, 9. For item number 8, the answer is D, 10 and E, 1s2, 2s2, 2p5, 3s1. For item number 9, the answer is S, P, D, and F orbitals. Letter D. For the last item, the answer is letter C. The atom is in the ground state. Count the number of your correct responses. I hope that you got, a very good amount of items correctly. But don't fret if you have a very low score, because that is just a pre-assessment. Let us now proceed to the last part of this video, a discussion on Bohr's atomic model and the energy levels. The light source in this diagram, I'm so sorry. Okay, so nagbibinata na si CJ ninyo. The light source in this diagram can be one of the metals emitting a specific color of light in the flame test. So, yung light source dito pwedeng isa dun sa mga, yung mga kanina, kung natatandaan ninyo. Yan. So, it can be one of these. So, a glass prism it has the ability to separate the light given off into its component wavelengths. This spectrum produced appears as a series of sharp bright lines with the characteristic colors and the wavelength on a dark background instead of being continuous like the rainbow. Instead of separating the light coming from the light source into a continuous band of light such as a rainbow, what this setup does is it separates the white light into the band of colors that are that look like slits. Okay, they are not continuous. We call this series of lines at the atomic spectrum of the element. So halimbawa, sodium, again, so say for instance sodium, okay, is emitting this kind of light, parang yellowish. If it's going to emit a yellowish light and then nasa-separate yung yellowish light into its component bandwidths pa, then the slits that will be given off in this photographic screen are going to represent the atomic spectrum of sodium. Yeah, so the color, number, and position of lines produced is called the fingerprint of an element. And if different samples of sodium are going to be burnt and harvesting light energy that came from it, they must have the same fingerprint. They must have the same atomic spectrum. So these are all constant for a given element. And if a new sample of sodium is going to be used for the same experiment, it must have the same results. Yeah. Okay, so for that experiment, if you put potassium, kailangan lahat ng mga potassium samples, isa lang ang kanilang atomic spectrum. So pare-pareho lang sila. In this case, sodium will always be having this kind of bandwidth of slits. Neon will be having these slits, and then hydrogen will only be having those slits. The bands of colors were taken as indications of energy transformations in the atom. Again, indicator itong word na to. So the bands of colors these slits were taken as indications of or indicators of energy transformations in the atom. So they are indicators of electrons that are moving from one orbit, from one energy level to another. So the orbits were called energy levels, represented by n, with a whole number assignments of 1, 2, 3, and so forth. So the first energy level is 1, the second energy level is 2, the third is 3, and so on. And so again, these slits are representations of or indications of the movement of electrons from one energy level to another. Okay, so now we are going to move on to this discussion. This looks like the Bohr's planetary model. Yeah, this is the nucleus. And then this is the first energy level, this one's the second energy level, and this one is the third energy level. That's why n is equal to 1, n is equal to 2, and n is equal to 3 in this case. Alright, so when an electron moves from a lower energy level to a higher energy level, there will be an absorption of energy. Again, if the atom is going to move, if the atom will be receiving energy, okay, an electron from the first energy level can move to the second energy level, and an electron from the second energy level can also move to the third energy level, and so forth. Okay, and then if there is an emission of energy, okay, that means an electron moved from the second energy level to the first energy level, or in other words, from a higher energy level to a lower energy level. Again, that will be causing the emission of energy. When an electron absorbs extra energy, say for instance, from flame, it moves from a lower energy level to a higher one. Halimbawa, ang atom na to, in-expose mo siya sa apoy. So, makakapag-absorb siya ng energy, and so, yung mga nasa first energy level ng mga electrons, pwedeng mapunta sa may second energy level. So, it gets excited and then stable in this case. Now, the electron can go back to a lower energy level, and in doing so, it releases energy in the form of light, with a specific color of light, definite energy, and wavelength. So, kapag yung atom, okay, nag-emit siya ng kulay ganito na light, ibig sabihin nun, kung anumang klaseng element ang kaya mag-produce ng ganong klaseng kulay ng light, ganong element din yung atom na yun. Sort of like, it's a way of identifying them. Bohr's model was only able to explain the electron of hydrogen, but could not explain those of elements with more than one electron. So that was the limitation of Bohr's planetary model. And so we're done with the first video for chemistry. I hope that you learned something. So remember that this is a video that is supposed to be used as a supplementary learning material for my grade 9 students in Angeles City. So if you have some comments, if you want to help me out in improving my future videos, you may, message me through my Facebook account. You can also comment down below with a very constructive comment. And if you have several questions, I just leave them in the comment section, and I will be trying my best to get back to you as soon as possible. Alright, so again, this is learning competency number 1 for grade 9 chemistry. And we are still in describing how the Bohr model of the atom improved Rutherford's atomic model. So I hope that you learned something, and that I'll see you in the next video. We're done with the 3 parts, and this is the knowledge catalog. See you.